Today, we are diving deep into the incredible story of how the Indian subcontinent was actually built. I mean, its massively diverse landscape, from the world's highest mountains to these ancient, sprawling plateaus, it all comes from a geological journey that is almost too big to imagine. So, let's get right into it.
It's a pretty wild thought, isn't it? But yep, it's absolutely true. The piece of land that we all know today didn't even start where it is now. It was basically an island continent on this long, slow, but completely unstoppable drift across a prehistoric ocean, heading straight for a collision that was going to change the face of the entire planet.
So when you look at a physical map like this one, you see all the features, right? The mountains, the plains, the plateaus, the deserts. But these aren't just random shapes on a page. Oh no. They are the scars and trophies from some of the most immense geological forces you can imagine. And today, we're going to uncover the story behind every single feature you see on this map.
Okay, so our story kicks off millions and millions of years ago. Back then, India wasn't a subcontinent at all. It was just a piece of a much bigger supercontinent, connected to Australia way down south of the equator. But deep inside the Earth, these powerful forces were starting to churn, setting the planet's crust into motion.
You can kind of think of the Earth's surface as a giant jigsaw puzzle made of these massive plates. Well, the Indian plate cracked, broke off from the rest of the puzzle, and just started drifting north. Now, this wasn't a quick trip, you know? It was a journey that took millions of years, crossing an entire ocean, all building up to one of the most important geological events in our planet's history.
So after its long journey, the Indian plate was on a direct collision course with the gigantic Eurasian plate sitting to its north. And we're not talking about a little bump here. This was a slow-motion crash that went on for millions of years, a crash that had enough power to literally build a continent from the ground up.
So you can picture it like this. You've got the Indian plate moving steadily north, and then bam, it slams right into the stationary Eurasian plate. This one single colossal impact is the origin event for pretty much India's entire geography, and it created three really distinct zones that we can still see on the map today.
So these are the three main characters in our geological story. First, you've got the Himalayas, this incredible mountain range that just buckled and folded upwards, acting like a giant crumple zone in a car crash. Second, there's the peninsular block. This is the ancient, really tough part of the Indian plate that acted like a rigid frame and just refused to give way. And third, the Great Northern Plain, which was basically a deep ditch that formed right in between the other two.
So let's zoom in and look a little closer at the two main players that were forged in this collision. You have the brand new towering Himalayas up in the north and the ancient unmoving peninsular plateau in the south. And believe me, they could not be more different from each other.
The difference between these two is just night and day. The Himalayas, geologically, they're the new kids on the block. They're weak, they're flexible, they're still being pushed higher even today, and they're carved by these fast-flowing rivers that create deep, sharp V-shaped valleys. The Peninsular Plateau, on the other hand, is the complete opposite. It's ancient, it's hard, it's incredibly stable. Its mountains are just the weathered-down nubs of what were once mighty ranges, and its rivers flow pretty gently through shallow valleys.
And right here, you can really feel that difference. I mean, look, on the left, you've got the sharp, dramatic, youthful energy of the Himalayas. And then on the right, you see the rounded, weathered, ancient stability of the peninsular hills. Just two completely different worlds, born from the very same event. It's incredible.
Okay, so we've got our two main landmasses, but what about that huge, flat area that's sandwiched in between them? And what about the deserts and the coastlines? Well, they're the next chapter of the story, and they were formed as a direct result of the mountains and the plateaus coming into existence.
So remember that big trench that formed between the Himalayas and the peninsula? Well, for millions of years, rivers flowing down from the new mountains and off the old plateau carried tons and tons of rock, silt, and sand with them. And where did they dump it all? Right into this depression. This massive basin was slowly filled in, creating the unbelievably flat and fertile northern plain.
And the sheer scale of this filling process is, well, it's just staggering. In some spots, the depth of all this river-deposited gunk is up to 2,000 meters. That is over a mile deep. A mile of rich soil built up grain by grain, year after year, for eons, creating one of the most fertile places on the entire planet.
And this plain isn't just one uniform slab of dirt. As the rivers came tumbling out of the mountains, they sorted all the sediment by size. The heaviest stuff, the big boulders, got dropped first, right near the foothills. The finer silts were carried much further out, and this created these distinct zones that change as you move south, from rocky ground to marshland to these vast fertile flats.
Now, if you look to the west, you find the Great Indian Desert. And what's really fascinating here is that the rock that's buried deep underneath all that sand, it's actually an extension of that same ancient peninsular plateau. It's old, hard land, but over millennia, super dry conditions allowed the wind to just blanket the whole thing in sand, carving out this incredible landscape of massive dunes.
All right, the final pieces of our geological puzzle are the islands. India has two major groups of islands, and just like everything else we've talked about, they have completely different origin stories, which adds this last fascinating layer to India's geological diversity.
Over in the Bay of Bengal, you've got the Andaman and Nicobar Islands. These are actually the peaks of a huge underwater mountain range, and they're linked to the same forces that created the Himalayas. They're volcanic, and they even have India's only active volcano on Barren Island. But then you zip over to the Arabian Sea, and the Lakshadweep Islands are a totally different story. Not volcanic at all. These were built entirely from coral deposits on an underwater ridge. So you have two island chains, made in two completely different ways.
And that brings us right up to today. But here's the thing, the story isn't over. That massive collision is still happening. Right now, as we speak, the Indian plate is still pushing into Asia, and it's causing the Himalayas to grow just a little bit taller every single year. So the map we've been looking at, it's really just a snapshot in time. The forces that built this incredible place are still at work, constantly reshaping it. So it makes you wonder, right? What do you think India is going to look like in another million years?